We will teach how to initiate, control, slow, and stop movements when operating a locomotive. Prerequisite trainings for this course consist of the 17 lessons pertinent to ground operations and the basic understanding of the air brake system. We at SafeRail recommend an employee have hands-on work experience as a ground employee prior to operating a locomotive. The objectives of this lesson are to understand buff and draft forces, controlling slack action, teach proven procedures when starting, slowing, stopping and controlling movements, and the use of the automatic air brakes to slow or stop movements. Buff and draft forces that occur within a train are known as slack action, also known as in-train forces. They are caused by cars within a train actually traveling at different speeds and causing adjacent cars' speed to adjust. Buff force is a term used to describe compressive coupler forces in a train. Buff force can be created gradually or suddenly. Shoving and coupling rail cars creates buff force. When shoving equipment, especially in a curve, too much buff force can cause enough lateral force to lift a wheel off the rail, causing a derailment. Understanding what buff force is and how it is controlled is necessary to prevent damage to equipment and track structure. To control buff force, use minimum throttle to start shoving movements. Couple cars with no more force than necessary to complete the coupling. Release both air and handbrakes prior to initiating a shoving movement. Avoid shoving heavy trains with empty cars near the engine. Sudden or excessive buff force can lift a wheel off the track. Use minimum throttle when starting movements and increase throttle gradually to allow forces to evenly distribute throughout the cars. To control in-train buff forces, use throttle modulation when planning stops. Throttle modulation is the action of adjusting the throttle to control train speed without the application of the air brakes. When starting a shoving movement, use minimum throttle and increase throttle gradually. When using brakes, do so gradually. Force is a term used to describe coupler tension force in a train and is created when pulling or stretching equipment. Excessive draft can cause coupler or knuckle failure. Excessive draft force in a curve can cause string lining. String lining is the action of equipment being pulled off the inside of a curve. String lining is the tendency of a train to form a straight line when pulled. String lining will occur in a curve. Excessive draft force will cause the equipment to climb the inside rail, causing a derailment. To control draft forces, release handbrakes and air brakes before starting movements. Use minimum throttle when starting a pulling movement. When pulling loads followed by empties and using air brakes to slow or stop, the empty equipment will slow more quickly than the loads and cause draft forces to rise. Use throttle modulation to control speed. The use of automatic air brakes gives the locomotive operator more control when slowing or stopping equipment. Train line continuity must be confirmed for proper automatic air brake operation. The brake system must charge prior to initiating movement. This chart represents minimum and maximum charge times when a brake system is empty. Keep in mind that these times are estimates. 2,500 feet of train line would be roughly equivalent to 50 rail cars. 8,000 feet would be roughly equivalent to about 150 car lengths. Keep in mind that during cold weather, it would be very likely that 8 minutes for a 2,500 foot train may not be enough time to properly charge a train line. Let's talk a little about train handling. Crew members must exercise judgment and plan ahead to operate their train safely and efficiently. The locomotive operator is responsible for controlling the slack in a train. Good train handling requires the proper combination of communication, throttle modulation, and air brake operation. For the purpose of this lesson, the definition of a train would be one or more locomotives coupled together or working together with or without cars attached. Controlling and limiting in-train forces are essential to safe train operation. Unless an emergency or other condition requires immediate speed reduction, make throttle position changes gradually, one position at a time, and make air brake applications to allow slack to adjust. The bell, whistle, and headlight are important warning devices a locomotive is equipped with. A check of these devices prior to operation is a must. Immediately prior to movement, the bell must be rung. When approaching structures, loadout areas, or any location where human activity may occur, the bell must also be rung. Prior to moving the locomotive forward, 2 long whistle sounds must be given in conjunction with the bell. Prior to moving the locomotive backwards, 3 short whistle sounds must be given, again in conjunction with the bell. When approaching public crossings, the bell must be rung continuously and the whistle must be sounded with 2 longs, 1 short, and a long. This whistle sequence should be timed to last between 15 and 20 seconds. The whistle must be sounded until the crossing is fully occupied by the locomotive. The headlight must be displayed on bright when approaching and operating over public crossings. Newer or updated locomotives may have a dynamic brake feature. A dynamic brake is an electrical device that converts some of the energy developed by a moving locomotive into an effective retarding force. Most older locomotives are not equipped with dynamic brakes. These are the procedures to follow when starting or accelerating on a level or ascending grade. Advance the throttle to a position sufficient to hold the train when necessary. Release the automatic brakes. Use the lowest throttle position to start the train. Allow the amperage or load meter to stabilize before increasing the throttle position. To increase speed, advance the throttle slowly, 1 notch at a time, to avoid excessive draft forces. When operating on a curve, use only enough power to start the train to avoid the possibility of stringlining due to excessive draft forces. If the train will not start, reapply the brakes, place the throttle in idle, and determine the cause. Applying power to a standing locomotive longer than necessary could damage the traction motors. The amp gauge indicates how many amps the traction motors are receiving. As tractive effort increases, amperage rises. There are restrictions on how long a certain amount of amps can be maintained before causing damage to the traction motors or generator. These restrictions are normally printed somewhere close to the amp gauge. These are the procedures to follow when starting a train or accelerating on a descending grade with locomotives not equipped with a dynamic brake. First, fully apply the independent brake. Release the automatic brake and wait for the brakes to release and the slack to adjust. Gradually reduce the independent brake until the train begins to move. On steep grades, it may be necessary to apply a few handbrakes on the cars next to the locomotive to help control the speed. When using this method of controlling speed, do not over-tighten the handbrake on empty equipment. Over-tightening will result in sliding and damaging the wheels. When slowing or stopping on an ascending grade, allow the grade to slow the movement. Reduce throttle gradually, one position at a time, to keep the slack stretched, while still allowing the train to slow. If necessary, make automatic brake pipe reductions to reduce the speed. When the train is approaching the stopping point, make a brake pipe reduction, actuate the independent brake, and maintain minimum power to keep the slack stretched. As the train comes to a stop, apply the independent brake. After the independent brake is fully applied, reduce the throttle to idle. On this slide, we have a picture of the automatic brake handle in the fully released position and a picture of the corresponding pressure gauge readings. The red needle on the left gauge indicates main reservoir pressure. Main reservoir pressure may fluctuate between 120 and 140 psi. The white needle on the left gauge indicates equalizing pressure. Note that the equalizing pressure has matched the brake pipe setting, which is indicated by the white needle on the right. The red needle on the right is the engine brake or independent cylinder pressure. Though not pictured, the independent brake here is fully applied. The white needle on the right gauge is the brake pipe setting. While remembering the brake pipe pressure on the previous slide, it was at 90 psi, note the white needle's readings of this slide. The automatic brake handle is in the minimum application position, or first service, and the white needles indicate an 8 psi reduction. While remembering the gauge readings of the previous two slides, refer back if needed. Note the pressure readings of this slide and the automatic brake handle position. The brake handle has been slid further into the application zone, and the gauges indicate a 17 psi reduction. A few slides back, we mentioned actuating the independent brake. This is also referred to as bailing off the independent brake. When using the automatic brakes to slow or stop a movement, it may be necessary to release the engine brakes to prevent wheel slide. To accomplish this, depress the independent brake handle. Push it down. This will fully release the application of engine brakes. If the operator wishes to reapply the independent to reset engine brakes, the handle can be moved back into the application zone to attain the desired amount of engine brake application. Use these procedures when stopping on level or descending grade with locomotives that are not equipped with dynamic brakes. If in power, reduce the throttle gradually to idle and wait for the slack to adjust. Plan ahead and at sufficient distance from the stop, make a minimum brake pipe reduction, which is usually 6 to 8 pounds, normally referred to as first service. Make further split reductions as necessary. When making brake pipe reductions, actuate the independent brake, then reapply the independent brake to maintain a slack bunched condition, but not allowing the locomotive wheels to overheat or slide. As the train comes to a stop, use no more independent brake than necessary to keep the slack bunched. Here is a close-up of an automatic brake handle. If the handle is moved to the far left, as in the photo, the handle is in the fully released position. The first stop to the right of fully released is the minimum application position, or first service. The progressive application zone is between the minimum application stop and the full service application stop. This is where the split reductions are made. The next stop is the handle off position. This position would be used to remove the brake handle. Finally, we have the emergency application position. How to make a non-emergency, unplanned stop. To stop in the shortest possible distance without using an emergency application, follow these procedures. Make a minimum brake pipe reduction before making a throttle change. When the exhaust stops, make additional brake pipe reductions as necessary. Consideration of train makeup must be taken into account when making additional brake pipe applications necessary to stop the train safely. This is what to do if the slack is stretched. While the brake pipe is exhausting, gradually reduce throttle while actuating the independent brake to maintain a stretched slack condition. As the brake pipe exhaust stops, make additional reductions as necessary. If the slack is bunched, reduce throttle gradually to idle. As the brake pipe exhaust stops, make additional reductions as necessary. As the train slows and comes to a stop, apply the independent brake. When an emergency brake application is necessary to protect life or property, use maximum braking effort while maintaining safe train handling techniques. When conditions warrant, use an emergency brake application by quickly moving the automatic brake handle to the emergency position and leave it there until the train comes to a stop. Actuate and hold the independent brake handle down in the actuating position. Then move the independent handle to apply the independent brake to a desired brake cylinder pressure to maintain maximum braking effort without sliding the locomotive wheels or creating excessive buff or draft forces. If in power, move the throttle to idle. There are two pictures of the automatic brake valve handle. In the left picture, the pencil notes the handle off position. This position would be used when setting this locomotive up in the trailing position in a locomotive consist. The next notch to the right is the emergency position, which would be used for an emergency application of the brakes. The pneumatic control switch, or PCS, will open and is timed so that it will not reset for 60 seconds following an emergency brake application. To reset the PCS, place the throttle in idle, then place the automatic brake handle in the emergency position for 60 seconds. After 60 seconds, move the handle to the release position, pausing briefly in the handle off position. The PCS should reset and the indicator light will extinguish. If it does not, repeat this procedure. This is the independent brake valve selection switch. Note that this valve is set in the lead position. This switch is used to set up the locomotive independent brake for controlling or trailing in a consist. A consist is defined as one or more locomotives coupled together to operate as one engine. If we were to rotate the switch 180 degrees counterclockwise to the trail position, we would be disabling the independent brake on this locomotive to set it up to be controlled by another locomotive coupled to it. This is the automatic brake valve selection switch. Note that this valve is set in the cut-in position. To set this locomotive up to trail, or to be controlled by another locomotive in the consist, we would rotate the switch 90 degrees to the out position. Then move the automatic brake handle to the handle off position. This is the locomotive brake pipe feed valve. It is used to increase or decrease brake pipe pressure. By turning the valve, PSI is increased or decreased. The brake pipe pressure change is indicated on the brake pipe gauge on the locomotive control stand. A setting of 90 PSI is recommended. The independent brake is used to set or release only the brakes on the engine. It works independently from the automatic brake system. The independent brake application zone is the entire area between fully released and fully applied. There is a hold notch for both fully applied and fully released. The independent brake shown here is fully applied. The throttle has 8 power positions: idle and shutdown. The gray handle pictured is the throttle. It is shown in the idle position. As the handle is moved to the left, the operator will note notches or slight resistance stops as the throttle is increased. There is an indicator window which will show which position the throttle is in as well, 1 through 8. If the throttle is pulled toward the operator and moved to the right of idle, the engine will shut down. The reverser is usually located directly below the throttle. In this photo, the reverser handle is removed. The reverser handle should be removed when the locomotive is in trail or is not being operated. The handle inserts into the receptacle shown and must be firmly pushed inward to snap into place. The reverser has 3 positions: forward or far right, centered, and backward. The amp gauge and the wheel slip indicator are important tools in the operation of a locomotive. The amp gauge indicates how much amperage the locomotive electrical system is putting out. The wheel slip indicator trips when the locomotive loses traction. It is readily visible on the control stand and lights up white. When the locomotive loses traction, the wheels spin and a tremendous amount of heat is generated on the wheels and the rail. If a locomotive is allowed to spin for more than just a few seconds, rail damage will occur. Sparks from this spinning will also cause fires if conditions are right. Caution must be used to prevent wheel slip from too much throttle being used. A locomotive's sanding system should be in good working order and should be checked at the beginning of the shift. The use of sand will greatly enhance the locomotive's ability to maintain adhesion to the rail. Whenever the pneumatic control switch, or PCS, is left open, the sanders will be on. So to eliminate the risk of the locomotive losing all its sand, a PCS should not be left open. When starting on a wet rail, on an ascending grade, on a curve, or if handling a lot of tonnage, the use of sand will greatly reduce the slip of the locomotive's wheels. Also, avoid the use of sand over switches if possible. The engine run, the generator field switch, and the fuel pump switch. These three switches are most generally located on the right side of the control stand. The engine run switch and the fuel pump switch must be on to allow the locomotive to run. The generator field switch is used to break or connect the current from the generator to the traction motors. Note, in this photo, the engine run and the fuel pump are on, but the generator field is off. The back panel switches and indicator lights may vary in different locomotive models, but generally include the following: the emergency fuel cutoff and engine stop switch. This switch will shut the locomotive down. The isolation switch has two positions. The run position allows the locomotive to be used for power. The start-stop isolation position will allow the locomotive to run, but will not allow the locomotive to respond to any throttle position other than idle or stop. To start a locomotive, the isolation switch must be in the start position. The headlight control switch allows the locomotive's headlight to be used as a single locomotive or to be used when the locomotive is being controlled by another locomotive. The hot engine indicator, crankcase pressure, or low water and the ground fault indicator are quite often on the back panel. The ground fault reset is used to reset the ground. If the engine continuously trips its ground fault, the locomotive should be checked by a certified mechanic. The low water pressure trip will shut the engine down if water pressure drops. When restarting the locomotive, it may be necessary to hold the low water button in for a few seconds until pressure has a chance to build. The crankcase overpressure will trip if pressure inside the crankcase rises to high levels. The crankcase overpressure is a safety feature. It is designed to shut the locomotive down to avert any pressure explosion inside the crankcase. For this reason, do not reset a tripped crankcase overpressure button. Call a certified locomotive mechanic to release the crankcase pressure and reset the tripped button. Both the crankcase and low water pressure buttons de-energize the governor and shut off the fuel supply by tripping the low oil pressure button, which is located on the front of the governor. The low oil trip button on the governor will trip and shut the locomotive down if the engine oil level drops and when the low water and or the crankcase overpressure buttons have tripped. Before resetting this button, check the oil level. This is a rather small trip button and, depending on the angle of the observer, may be obscured by the tubing. It will protrude about 1.5 inches and show red when tripped. This button needs to be pushed in to start the locomotive. The oil button shown here is in the run position. The engine overspeed trips when the RPMs reach a critical level. It is located between the governor and the diesel engine. If it is found to be in the 1 o'clock position, it is tripped. The 11 o'clock position is normal. The overspeed will sometimes trip if the throttle is advanced too quickly. To start the engine, place the Run selector switch in the Isolate Start-Stop position. Be certain the battery knife switch is on. Turn the fuel pump and the local control breakers in the breaker panel to on. Flip the fuel pump and the engine run switches on the control stand to on. The generator field switch should be left off. This start switch is located just inside an access door about halfway down the walkway on the operator's side. The access door is usually stenciled "Engine Start." Prime the engine by turning the switch to prime and holding for about 10 seconds or until the sight glass fills. Then turn and hold the switch to the engine start position. Pushing the lay shaft inward about 1/3 will help the engine start. As soon as the engine starts to run, release the lay shaft and the engine start switch. The lay shaft handle is just to the right of the start switch and is attached to the governor and the fuel rack. If in the event the locomotive will not shut down with the fuel cutoff buttons, the lay shaft handle can be pulled outward or toward you and held until the engine dies. We covered a lot of material. So what did we learn? We learned about in-train forces and how to control them through throttle modulation and air brake applications. We learned how to initiate, control, slow and stop equipment on various grades. We learned how to read and interpret fault indicators, gauge and amperage readings. We learned how to operate a locomotive without causing damage to the rail, the equipment, or the environment. We learned how to shut down, troubleshoot, and restart a locomotive. Any questions can be directed to Ken H. at railsafetraining.com. Thank you.